Slope point form. Slope and point. Slope and, well, let's do this. Solve the following equation. So we have this little warm up here, right? So we're going to cross multiply. 3 times x plus 4 is equal to 2 times 5. Now, since that's 10 and I can't divide by 3, I'm going to expand this out. 3x plus 12 is equal to 10. 3x is equal to negative 2, and x is negative 2/3. State the equation of the line shown to the right. Okay, so here's 0. So here's my y-intercept is at 3, and my slope is 2 down and 1 to the right. So y equals negative 2x plus 3. It's easy to identify the equation because the slope and y-intercept were easy to find, right? I mean, look, this is, there's 0, that's the y-intercept, and the slope, easy to find. Wouldn't be so easy if, you know, let's say we had a line that did this. Right, so we can't identify the y-intercept easily, and probably from this we can't really identify the slope easily. Like, what if it were negative 17 over 16 or something, or some really weird number? It would be really hard to do. So describe some scenario where slope and y-intercept are not easy to come by. Alright, in order to graph or determine the equation of a line, we either need one point and the slope, or 2 points. Slope y-intercept form from the equation involves 1 point with the y-intercept and the slope. But what if we're given a point and the slope, but the point we're given is not the y-intercept? Well, here's the slope formula. M equals y2 minus y1 over x2 minus x1. We know that the slope of the line on the grid above is negative 2, right? Or negative 2 over 1. Using this value along with the points, okay, so m is equal to y2 minus y1 over x2 minus x1. Negative 2 over 1 is equal to, okay, so we get y minus 5 over x plus 1. Now, since I want to arrange so y is isolated, and you'll note here that y is positive, it's best to have the positive down here and the negative up here. So we get 1 times y minus 5 is equal to negative 2 times x plus 1. So y minus 5 is equal to negative 2x minus 2, adding 5, y is equal to negative 2x plus 3. And how does that compare? Well, that's the same as the equation above. It's the same. So the slope formula is a valid way to generate the equation of a line. The equation of a line with slope m that passes through a known point x1, y1 is m is equal to y minus y1 over x minus x1. This equation can be rearranged, cross-multiply, to get slope point form, which is y minus y1 is equal to m x minus x1. This form is mostly used when the y-intercept is not known and too time-consuming to determine, or the precise value of the y-intercept cannot be determined from a graph. Slope point form can generate the equation of a line using the slope and any point. Okay, so we don't need the y-intercept. If we have it, life is easy, but examples where you are given the slope and 1 point that is not the y-intercept. Point the line passes through is 3, negative 4. The slope of the line is 2/3. The equation of the line, so it's y plus 4, right? It's y minus negative 4 is equal to 2/3 x minus 3. And that is point slope form. An x-intercept of negative 5 tells us the x value is negative 5, the y value is 0. So y minus y1, which is 0, so we don't bother with that, is equal to m 1/4 x minus negative 5, so that's x plus 5. Y plus 6, right? Y minus negative 6 is y plus 6, is equal to negative 5 halves x minus 1. Graph line A from the question above on the grid and label it. Graph the line. Okay, so we go through. So remember, graphing, we don't really need anything fancy, right? Passes through 3, negative 4, and has a slope of 2/3. Passes through 3, negative 4. Slope of 2/3 is up to 1, 2, 3 to the right, and down to 1, 2, 3 to the left. And there's the line with arrows. Remember, just because we don't draw arrows on stuff because it's not easy in the graphing stuff we use, doesn't mean that you don't. Convert the equation into slope y-intercept form. Well, okay, so to convert, let's start with the equation. Y plus 4 is equal to 2/3 bracket x minus 3. So we're going to multiply through by 2/3. Y plus 4 equals 2/3 x. No, 3 times 3 is 2/3 of negatives minus 1. So y, minus 2, right? 2/3, right? That is a 3 over 1. 3's cancel, we're left with minus 2. So y is equal to 2/3 x minus 6, which matches up with what we see here. We have a negative 6. So verify the y-intercept from your equation. Minus 6 matches up with the y-intercept of the graph we drew, and it does, although it wasn't going to because I'd messed up a little, but I fixed it, so it's all good. For each equation, state the slope and the coordinates of a point on the line and sketch the graph. So the slope is negative 3. The point on the line, remember, it's x minus x1, so if that became a plus, so we have the point negative 5, 4. And draw that. All right, let's color this in. Okay, this little purple. So point on the line is negative 5, 4. Slope is negative 3, says go down 3, 1, 2, 3 down. 1 over, 1, 2, 3. 1, 1, 2, 3. 1, 1, 2, 3. 1. Also says go the other way, go up 3, left 1. Okay, got a lot of points on there. Lots of points is good. Anytime we draw a line, it's going to fill the whole grid, right? Because this line goes on forever, so we're not just going to stop. So that's A. Y plus 6 is equal to 2/5, so the slope is 2/5. Okay, remember it's x minus x1, so x1 is positive. Y minus, so we have opposite signs, so 1, negative 6. 1, negative 6 is my point, and the slope is 2/5. 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. If I can, I like to fit more than 2 points. Okay, sometimes we will draw with only 2 points, but if we can get more points on there, the merrier. And that's B. C, slope is 2. X value, well, when you subtract, right? And then the y value is 0. So going through the point, 4, 0. Oh, right, let's pick a color. We have a slope of 2, 1 up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Positive slope, right? Down 2, left. Down 2, left. Down 2, left. I mean, you can draw it faster than you can say it. Lots of yellow dots, right? They should all be in a straight line, so when you line them up with your ruler or the base of your calculator, then you can draw. And that is C. And this was B. C was yellow. D will be green. It has a slope of -1, has an x value of 0, right? Because we don't see anything there, so there is nothing, and a y value. Remember, it's y minus y1, so y1 is +6. So we have 0, 6. Slope of -1, down 1, oops. Yeah, down to the right, down 1 over 1, and just going on this diagonal, really, right? And then the same thing going this way, and draw the line, which I had said was going to be green, but it's black. And there we go. Okay, so drawing the, given the equation of the line, and just using the slope and a point on the line to help us draw the line. On the grid, draw the line with a slope of -3/2 that passes through -2, 7. Okay, well, we've been doing a bunch of these, so let's use blue. We haven't used blue. -2, 7. Slope of -3. So remember, that's -3/2, or that's 3/-2. This says down 3, right 2. 1, 2, 3, right 2. Down 3, right 2. Down 3, right 2. Down 3, right 2, and also says up 3, can't go up 3. So I'm pretty much done. And we draw the line and run off the grid and draw the line, and there we go. So we have drawn the line. State the equation of this line using the slope and the point -2, 7. Okay, so we know the slope and we've got the point. So it's y minus y1 is equal to mx minus x1, right? Formula. Y minus 7 is equal to, okay, we know the slope is -3/2 x minus x1 minus -2, which is x plus 2, and that's the form. We're just using this form for the equation. But this can be converted into slope-intercept form. How do we do that? Well, we're going to expand this out. So y minus 7 is -3/2 x minus 3. Okay, so we have -3/2 times 2 is -3. Add 7 to both sides, -3/2 x plus 4, and we can see that it verifies with the graph, which has a y-intercept of +4. State the coordinates of one other point on the line besides the y-intercept. Okay, here's one other point. This is 6, -5. State the equation of this line using the slope and this point in point-slope form. Y minus y1 is mx minus x1. Y plus 5, right, minus y1 is equal to -3/2 x minus 6. Now this looks like a totally different equation than this. But let's convert to slope y-intercept form. Okay, so y plus 5 is equal to -3/2 x. Okay, 2 goes into this 3 times, so we'll get +9. And y is equal to -3/2 x plus 4. Now, wait a sec, that's the same as this. So the slope-intercept form is the same. What do you notice? The usual, right? The same. In general, the equation might look different when it's written in slope-point form, depending on the point that you use, but the m value will be the same. But when converted to slope y-intercept form, we can see that it is in fact the same equation. Does the point 16, -19 lie on this line? Maybe. Okay, how would we tell? Well, we can plug 16, negative 19 into any of the forms of the equation we have. So let's start with this and see what happens. So we've got y minus 7 is negative 3 halves x plus 2. Now, what I should get is a true statement. If I put negative 19, negative 3, and we put 16 in here, or 16 over 1, okay, well, plus 2. So 2 goes into 16 8 times. This gives me negative 26. And wait a sec, it's not plus 2, it's minus 2, isn't it? No, it is plus 2, x plus 2. No, but that's in brackets. Okay, erase. Okay, and this is 16 plus 2. Okay, that's 18. So that's negative 26. Negative 19, negative 3. So that's 18 times negative 27. And I can see we're going to be rewinding this. And, well, wait a second. So, no, it doesn't lie on the line. All right, let's try it in. Right, that's not true. Okay, let's try it in the slope. So negative 19 is negative 3 halves times 16 over 1 plus 4. So 2 goes into 16 8 times. So negative 19 is negative 24 plus 4. Negative 19 is negative 20. Not true, so no. Okay, and so the justification, no. It does not satisfy. And by satisfy means makes it true. It does not satisfy the equation. When values satisfy an equation, they will make a true statement. So this is an untrue statement, or what we call false. 11. Write the equation of each line, both point-slope form and slope y-intercept form. All right, well, slope y-intercept is not going to be easy to find here. Okay, so slope is, what do we got? 1, 2, 3, 4, 1, 2. So the slope is 2. We can use either point. So I'm going to use this one just because it's positive, so 5, 1. So y minus y1 is equal to m x minus x1, right? Where do we always start in math? We start with the formula. Y minus 1 is equal to 2 bracket x minus 5 y minus 1. Okay, now that's points. That's point slope form, right? This is 2x minus 10. So y is equal to 2x minus 9, right? Add 1 to both sides. And so if we kept this going, it should intercept at minus 9. So there's point slope form. And there's slope y-intercept form. Oops, moving stuff around. Okay, not an easy y-intercept to find, right? But we can calculate the slope. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the slope is negative 6 over 10, which is negative 3 over 5. So I should be at 1, 2, 3, 1, 2, 3, 4, 5. Yeah, so there's another point. But we use the 2 points that we found, right? And I was just counting. Counting is easy. We could have used the slope formula. But hey, you can count. So y minus y1 is equal to m x minus x1. Choose a point. So this is 4, negative 5. Or we could choose the point, negative 6, 1. Doesn't matter, except then we'll get different looking equations, right? So y plus 5, I'm going to use this point, is equal to negative 3/5 x minus 4. Okay, and that is point-slope form, right? We've got the point, we've got a slope. Slope-intercept, y plus 5 is negative 3/5 x plus 12/5. I have to extend the page. So y is equal to negative 3/5 x plus 12/5 minus 25/5, right? Now, in order to add this 12/5 and to subtract 5 from both sides, the 5 has to come out as negative, or as 25 over 5. So we get minus 13 over 5, right? Which is minus 2 3/5. And, you know, I think we can imagine that's 3/5 of the way. And we have our slope y-intercept form here. What about this? Examples where you are not given only 2 points. Write the slope point form of the equation of each line. Where you are not given only 2, what the heck does that mean? Where you are given only 2 points. How about that? That would make a lot more sense. So what if I have 2 points? I need the slope. Okay, well, guess what? You have a formula for slope. So the first thing we need to do is calculate the slope. So we're going to go with 2 plus 1, right? 2 minus negative 1. I'm getting old and lazy, so and negative 7 minus 5. So that's 3 over negative 12, or negative 1/4. So now, the formula, y minus y1, is mx minus x1, y, I'm going to use this guy, so y plus 1 is equal to negative 1/4 x minus 5. And if you did it the other way, it'd be y minus 2 is negative 1/4 x plus 7, right? And that's slope point form, or point slope form. Passing through, okay, again, same deal, right? And every time you write down slope, you do start with the formula. So, I'm going to go the other way. So we'll go negative 3 plus 27, just to give a positive, right? Negative minus negative, and then negative 7 minus 9. So that's 24 over negative 16. So it's negative 3/2, right? Since both of these are divisible by, and if you're lazy, 24 divided by 16, math to a fraction, and we get 3/2, right? But we know it's negative because there's a negative there. Formula, y minus y1 is mx minus x1. Let's go with this, we'll have pluses all over the place. Y plus 3 is negative 3/2 x plus 7. And if we went the other way, it'd be y plus 27 is negative 3/2 x minus 9. And if you converted these to slope y-intercept, they would be the same. The total cost for 10 books is $80. If the rate of change is $5 a book, state the equation where C represents the total cost and N represents the number of books in slope point form. Okay, so we have 10 books is $80, and we have M is equal to 5. So y minus y1 is mx minus x1. Y minus 80 is 5x minus 10. There's the slope point form. Convert into slope y-intercept. I prefer a lowercase s there. Y minus 80 is 5x minus 10. Y minus 80 is 5x minus 50. Y is equal to 5x plus 30. Right? We're going to add 80 to both sides. Use the equation to find. Now, does that work? So if I plug 10 books in there, yeah, 10 plus 10 times 5 is 50, plus 30 is 80. Yeah, I'll get $80. Plug 0 books in there, so there's like a $30 charge, right? And then $5 a book. Use the equation, so y is equal to 5x plus 30. Y is equal to 5 times 100 plus 30. So y is 530. An equation where c represents the c's. Okay, here, let's do the correct one. This will be like c minus c1 is equal to m n minus n1. So this will be c minus 80 is equal to 5 n minus 10. So this is c is equal to 5n plus 30. And this is c. Do they want a function? No, equation. So 5 times 100 plus 30. So ignore the black. It's all about the purple. Because of the requested use of the variables. And I think we're done.